Okay, this is our first day looking at limits and continuity problems from old AP exams. Okay, so the AP exam is broken up into two parts. The first part is multiple choice. Anytime the problems are numbered 1 through 30, those are ones from the no calculator section. So the first 30 multiple choice, you do not get to use a calculator at all, not even a scientific calculator. So always kind of look at like the number that's pasted with the problem. This is just me numbering how many problems we're going to do. So like, for example, this first problem that we're going to do here in a second is number 5. So that would have been on the no calculator section. This is weird. They like jumped then to 76. So anything, so anytime it's numbered 76 to 90, that's like the second section of multiple choice. Those are the ones that you would be able to use your graphing calculator. Okay, that's how the free or the multiple choice is set up. We'll talk about free response in a second. Okay, let's look at this problem. That's gonna be interesting as well. Oh, it does stay. The ink stays on the page. I thought it would scroll with me. Good deal. Okay, here we go. And I'm just going to kind of go through these with you guys. So the graph of the function f is shown above. Which of the following statements is false? So as I mentioned, a lot of the times they like to kind of be like tricky with these multiple choice ones. You just got to read it very carefully. Okay, the limit as x approaches to exist. What do we think? Is that true or false? True. Yeah, the limit exists. Good. Okay, so it's not that one. And a lot of times it's just process of elimination. Sometimes with these multiple choice ones too. The limit as x approaches 3 exists. True or false? True. That exists. And remember, none of your work is graded, so you don't have to state what it is or anything like that. This is multiple choice. They literally just grade your answers here. The limit as x approaches 4 exists. Ooh, false. There it is. That's the one. Now, if we were to keep going here, the limit as x approaches 5. That exists. That's true. The function is continuous at x equals 3. Can I trace over here without picking up my pencil? Yes, I can. That one's also true. Okay. So that one you wouldn't have gotten a calculator for. Don't really need it anyways, but. Oh, we just did one of these like right at the end of class today. The limit as x approaches infinity of x cubed over e to the 3x. So picture plugging in infinity. And again, you don't have to use your limit notation or anything like that because this is all multiple choice. You just get scratch paper. So if I have infinity to the power of 3, that's going to be pretty big. All right, but if I have e to the power of 3 times infinity, we talked about how that exponential growth grows so much faster. So when this case happens, because you can't divide by like the largest power in the denominator, because my denominator is not a polynomial, you have to ask yourself, okay, like which one kind of like overpowers or which one's larger? And in this case, my denominator, this one's going to grow way faster. So anytime we're dividing by something large, that just goes off to 0. So this limit would be 0. Okay, kind of makes sense. And also, this is number 7. So don't bank on like, oh, I could have just looked at my graphing calculator and looked at my end behavior, my right end behavior for this function, because this one, again, you wouldn't get your calculator for. I don't know if any, I think there's maybe one on here that you do. Yeah, number 6. Okay. This one was the very first problem on a multiple choice question. I don't remember what year I took all these from. I was just cruising through looking for ones with limits and continuity on them. All right, the limit as x approaches infinity. So when you see something like this, we're like, okay, I want to try and divide by the largest power in my denominator. Now, this function is weird. It's like already factored for us. So if I want to divide by my largest power, I can like multiply this all out. I know you can kind of visualize that and see that it's x squared. But personally, my first step here would be to kind of like multiply everything out so I can get like 2 polynomials in standard form in my numerator and my denominator. So if I multiply my numerator and my denominator out, and I think, I don't remember exactly how much time you get, but I think it's like you can spend like either 2 minutes or 1:30 is like on each problem to like finish in time. So you want to do these quickly. And again, on here, your work isn't graded, so don't worry about carrying down your limit notation. Just go ahead and multiply that out. So you get like 6x minus 2x squared plus 3 plus x over this. You could all do in one. Let's see, plus 2x minus 3. I'd probably kind of put this in standard form. You can clean it up a little bit. Negative 2x squared plus 7x plus 3. And then we're like, okay, we need to divide these all by the largest power of x. So again, I'm not wasting my time writing my limit notation. I know what I need to do. This one got cut off a little, x squared. Okay. So like from here, basically any time you have a larger number of x's in the denominator, when I plug in infinity, it's going to go off to 0, right? So like from here, I would just like cross these off. Like those are all going to be 0. We did a lot of those examples. This is going to be negative 2. Okay, here we got 0, 0. X squared over x squared is 1. So that limit would be negative 2. B. Okay, so I want to be clear that on our quizzes and tests in class, we need to do like the proper like limit notation and stuff, and you would, need to show me the limit as x approaches 0, and that those all equal 0. But when we're trying to do things quick on multiple choice, nobody's grading your work. Okay, not bad. You guys feel like you could have got those probably right on your own? Yeah. I bet you could get this one. Actually, I think I put a problem very similar to this on your first quiz. So again, number 3, no calculator. If you want to make notes of that as we go, you can. You don't have to, but this will be on the no calc section. The limit as x approaches 0, sine of x times cosine of x, all over x. And I see this little magic formula we have to know. So I could split that up. Right, this is what we practice a lot of these with our trig ones. This is 1. Here I can direct substitute. You guys know what the cosine of 0 is? 1. So that's 1. Okay. Ooh, I like this problem. Number 5. This goes along with what we talked about in 3.5. The line y equals 5 is a horizontal asymptote to the graph of which of the following? So, horizontal asymptote. Change it my color here. Horizontal asymptote. We find those by taking the limit as x approaches positive or negative infinity. We're looking for like our end behavior of our function, right? So I'm trying to think like which of these functions, when I take the limit as x approaches positive or negative infinity, am I going to get a limit of 5? And again, I know my calculator here, so I can't just graph these and look which one has a horizontal asymptote. That'd be way too easy. So, I mean, possible elimination right away. Y equals 5x, that's a linear function. We know that's going to go on forever. That's not going to have a horizontal asymptote of 5. Okay. Here, 1 over x minus 5. This one has a vertical asymptote of 5. But if we were to take that, divide by the largest power of x, we're end up getting 0 in our denominator. And you might know just from the look of this graph that has a horizontal intercept or horizontal asymptote at y equals 0. Okay, here you get, 0, so it's not that one. I'm going to come back to this one. This one's a little bit tricky. D, if I divide everything by my largest power in the denominator, which is just x, I end up getting 5 over 0. That one drops out. Minus 1, I get negative 5 as a horizontal asymptote. Okay, everybody follow what I'm doing? The last one, my largest power of my denominator is x squared. So if I divide everything by x squared, okay, anything that's basically has a larger value in the denominator, those are just going to be zeros. I just cross those off. I'm trying to do this quickly. I see I get 20. I don't know why I just did that. Okay, I get 20. That's the other one. 20 in my numerator. 4 in my denominator. Ooh! That one looks like I got a vertical asymptote of, I keep saying vertical. Horizontal asymptote of 5 if I were to actually do like the whole limit thing. Okay, so we're thinking that one looks promising. We already ruled out that one. Now this one here, folks, think of the sine curve. It looks like this, right? It kind of like oscillates. So it's going to be some value over a really, really large amount, because obviously like I direct substitute in infinity or negative infinity, so that one's going to be actually 0. That one has an asymptote of y equals 0, so it does end up being e. Okay. So I don't mean to be like sloppy with my work, but I'm just trying to like really like emphasize like how you should go about right away doing multiple choice. You don't have to be perfect in your work. You just have to work quickly. All right. E, love that problem. Okay, this one would have, because it's numbered 77, this one would be on the calculator portion, but obviously looking at the problem setup, probably not going to need our calculator, but it says, the figure above shows the graph of a function f with domain 0 to 4. Which of the following statements this time, which of the following statements are true? All right, let's go through these. Kind of hard to see, but that says the limit as x approaches 2 from the left. All right, what do you guys think? Does that exist?
Yes.
Yep, the left-hand limit exists. That's true. The limit as x approaches 2 from the right, does that exist?
Yes.
Yes, that's true. Does the limit as x approach 2 exist?
No.
No, because they're approaching 2 different values. That's false. Okay, so my choice here would be 1 and 2 only be C. And I've started to even put some of these types of problems on your quizzes because that's how they like to word a lot of these problems. Okay, any questions so far? I think we have about 3 more multiple choice ones before moving to the free response. Number 19, no calculator question. What are all the horizontal asymptotes? Anytime I see that, I'm thinking, okay, my end behavior, my limit as x approaches positive or negative infinity, of the graph of 5 plus 2 to the x over 1 minus 2 to the x. Okay. I think I remember the statistics on this question that like it was a very, very low like amount of people got this problem right. Like it was missed very commonly. I don't remember exactly what it was because this is what people forget to do. So they probably look as the limit approaches infinity, but we have to look at both because sometimes we can have 2 different asymptotes on the right end behavior and on the left end behavior. Okay. Now, this one is not a polynomial, so I can't use that tactic of dividing by the largest power of x in my denominator. So instead, I kind of just have to look at what's going to grow the fastest or what term's going to kind of like overpower when I plug in infinity. So it helps you visualize it if you go ahead and like direct substitute in infinity. All right, so let's do this positive infinity one first. If I have 2 to the positive infinity, that plus 5 is really not going to do much, right? So that plus 5 really kind of drops out there. It's insignificant when I'm talking about an exponential growth with plugging infinity into my numerator. Same with this plus 1. So I kind of end up algebraically with 2 to the power of infinity over negative 2 to the power of infinity. And 2 to the power of infinity over 2 to the power of infinity. Anything over itself is just 1. But in the denominator here, that's technically a negative 2, so that ends up simplifying to negative 1. Okay, kind of a weird one. So a lot of people get that one, They usually get like one or the other. But if we look at when x approaches negative infinity, watch what happens here when I direct substitute in negative infinity. I have 2 to the power of negative infinity. Now, exponent properties, that'd be the same as 1 over 2 to the positive infinity. Same thing down here. Okay, does that make sense? That algebra? Negative exponent property. Now I have the case of I have 1 over something super, super, super large. So that's going to be 0. Here I have 1 over something super, super large. That ends up being 0. So I end up with 5 plus 0 over 1 minus 0. I end up with 5. So this one actually has 2 horizontal asymptotes at -1 and at 5. Okay. We're going to skip this one because we haven't done absolute values yet. It's at the end of our notes. We're going to do that tomorrow. So we will come back to that problem maybe next Thursday. Oh yeah, let's get into some continuity stuff. Enough with these horizontal asymptotes. All right, this is number 10 on multiple choice, so no calculator on this one. So again, with this like arithmetic too, you have to be able to algebraically do stuff without your calculator. Let f be the function defined above. For what value of b is f continuous at x equals 2? Okay, so our big idea with continuity is that the limit as x approaches whatever x value we're looking at, in this case 2, has to be the same as when I plug in 2 into my function. It has to be the same as the output. That's our big idea with continuity. The limit has to exist, the value has to exist, and they have to be the same. All right, so look at my piecewise function here. This first piece is defined for every single value except when x is 2. So that'd be the piece I'd use to find the limit. That would show me where it's coming in on the left and on the right, because it's defined for every single value except at 2. And then obviously, for when x is 2, we're going to use this piece. So f of 2 would be b. All right, now I got to work with this limit over here. So my first step would be to direct substitute, but look what happens if I were to try to plug in 2 into my denominator. I'd have 2 minus 2, I would have 0. So looking at the top, I'm like, ooh, that looks like something I could maybe try and factor, because that would be my next step. If I can't plug 2 into my numerator, or into my denominator, if I'm dividing by 0, I got to try some algebra. Oh, this is multiple choice. I don't have to carry down the limit notation. Okay, I can just kind of do my work here. That factors into x minus 2 times x minus 5. X minus 2's cancel. You can even just do this, draw your arrow. I'm left with x minus 5 over b. And now I can plug in 2 for x. Now I can direct substitute. So I end up getting 2 minus 5 equals, I'm going to multiply that b over b squared. Okay, so I end up getting -3 equals b squared, and I try to solve for b, and I'm square rooting a negative, so there is no value of b that would make that function continuous. Okay, we've done some problems kind of similar to that. Aren't these fun? You think so? I love, like, reviewing for AP exams, like, the best part of this class is so fun. Okay, last multiple choice one. And then we'll maybe stop it there, and we'll pick up the FRQ maybe next week. So, this one, no calculator. The figure above shows the graph of the function f. Which of the following statements are true? Ooh, another one of these. Okay. The limit as x approaches 2 from the left is the same as f of 2. All right, let's just tackle that first piece. What is the limit as x approaches 2 from the left? -1. Yep. What is f of 2?
-1.
Also -1. Okay, that's true. Those are the same. Next one. The limit as x approaches 6 from the left. What does that look like? It's going to be
-1.
-1 again. Is the same as the limit as x approaches 6 from the right, which is also -1. Okay, that one's looking like it's true. Next one, the limit as x approaches 6, which since the left and the right are both -1, that limit would be -1, is the same as f of 6. What's f of 6 according to my graph? -3. And that one's false. Bless you. So 1 and 2 only. I feel like it's that option a lot. Okay. I'll just talk about the overview of the free response. So there's 6 questions on the free response portion. The first 2, you get to use your calculator. And the last 4, you do not get to use your calculator. All right, so we go through these again. Obviously, like I just numbered them kind of more for myself of how many. Like question 6. So on this one, that would have been on like a no calculator type of problem. That one's from 2008. Obviously, there's like multiple parts of them. We've looked at previous free response questions when we did our little exploration. We're only going to be able to do pieces of it for now, but we'll stop there and pick it up on next week. Okay, thanks for watching. I'm going to look at